Okay, so here for chapter 5, we're dealing first with pie and ice cream, which in this case are perfect complements, and our income. Sorry, in my case, I had income of 36. I had price of ice cream at $3. So if I just make those two little changes here, my math will be okay. Um, Makes sense here, right? 3 and 36. That's why I have an intercept here of 12. And then all we need to do in this case here is look at the x-intercepts here. If it's at 36, then the price of pi is $6 versus the price of pi here being $3 versus the price being $1.50. And so then we just do that backwards calculation. How did I get those numbers? Because I took my total income of 36 and divided it by my x-intercepts, which I would then use here. If we're starting to look at the price of pi, I would have a $6 one, $3 one, and $1.50. So those are going to be relevant points here. When it is $6, looks like my optimal number of pies is 4. Okay, so I'm going to go 6 and 4. When it's at 3, my optimal number is 6. And when my pi is $1.50, my optimal number of pies is 8. And then we connect the dots, and there would be my demand curve. Okay. Number 2. This should be largely definitional, so in the interest of time, I'm going to skip it. Number 3. We're choosing between magazines and books. I don't know why they they do it this way. If it were me, I would make this a drop-down graph, but they didn't. Which just your life would be a lot easier because all you're really looking at here for your price consumption curve is you're then looking at the various prices and your quantities. And so you'd be basically plotting these points over here where the price is now changing from 15 to 750 to 5 to 3. So right, so you have 15, 750, 5, and 3. And then you'd be looking at those various points and you'd be graphing it out like that based on these optimal numbers here. Okay. In number 4 here, we, in my case, had a price here of 2 and I had a price here of 1. And what we're asked to do here is draw the angle curve. The angle curve is going to tell us purchases based on our level of income. And so what we're going to do there is we're going to hold the, we're going to look at the prices being held constant, but we're going to allow our income levels to change. So these prices will stay the same. But what we can see is that we're going from, for pi, we're going from 4 to 6 to 8, which is going to go from so we have to find out our income level here. So the price of pi, 2 times 8 is 16. And for ice cream, oh, duh, because it's going to be, sorry, I was like, why is that math not working out? Sorry, they're doing, okay, never mind. Sorry, I need to just reset. Go back to drawing. Okay, let's just stay with theirs. Price of 75, price of 75, so that makes sense here. So what would that be? That would be 8 times 0.75, which is 6. So it'd be a $6 income. So if my income is 6, four pies. Now 12 times 0.75. So now at a budget of 9, I am at 6. And now at a budget of 16 times 0.75, which is 12. At a budget of 12, which again is now 16 times the price of 0.75. At a budget of 16, my optimal amount is 8. And so my angle curve will go up like this. Okay, I'm going to pause here. Okay, now we got Hugo seeing donuts and coffee as complements. He has to eat a donut with a cup of coffee. He won't eat a donut without a cup of coffee, or drink coffee without a donut. Let's see. Okay, Hugo, let's look at your angle curves. We've got 2 and 2 here for our we got 2 and 2 for our prices here, so makes sense. We're at a 1-to-1 ratio here for our budget constraints, and then our indifference curves are shaped like typical indifference curves when they are perfect complements. So the question would be is, what does his weekly budget have to rise by for him to buy one more donut? Well, it would have to rise by both of them, PD and PC, right? Because they need both of them to be able to have a higher indifference curve. So it'd have to go up by the price of a donut and by the price of a coffee. And regardless of what your numbers are up here, it doesn't really matter because it's definitionally speaking, you would have to be both your donut and coffee that would have to go up. Okay. Okay. Okay, I'm going to pause here. I have to go to a my child's event. So I'm going to pause this and then I'm going to resume this here in about an hour or so. Okay, here in number 6, we're looking at 3 different budget constraints. The one for 400, 600, and 900. So that would mean that we're looking then at this relevant 400, this 600, and this 900. And we're looking at it for good X. And we can see it's going from 30 to 35 to 40. From 30 to 35 to 40. Thus creating an angle curve that looks like that. How do I get those numbers? I got them from down here. So essentially what you're able to see, and kind of as it demonstrates the theory here, is that an angle curve represents the same information, just giving us a different perspective. Where again, income is now on our y-axis. Obviously, we lose information though, because now we don't have any notion of what's happening in good y, obviously in this space here. Okay. Number 7 is largely definitional, so I'm going to skip it for right now, just in the interest of time. Number 8 is also definitional, so I will skip that as well. Again, my reason for skipping it is to keep these more or less reasonable size. Okay, again, I'm going to change this slightly just to reflect what I have here. I have a 9 here, and I have college textbooks costing 100. Used books I have costing 50. 20% increase in new texts, and I have an 8% increase in used texts. And he's being given $180 extra. Okay, so I'm just adjusting it so that my notes are the same as what we've got here. So that would mean 9 books at 100. With this increase being given $180. So if his total budget is $180, there's a 20% increase for new, 8% for used, he would have been spending $900, right? 9 at $100 a piece. And he's going to get this increase of 180. Is he going to be the same or worse or better after that change? The idea here would be is that if he's being given this $180 increase, he would at least be as well off. Now, how did I know that? So the correct answer is here. How did I know that he'd be at least as well off? Because essentially, right, if you only bought new textbooks, he would have spent $900, and then after the 20% increase, he would have spent $1,080, because that would have been the after the price change, 20% higher, which is $180. Now, if he's given $180, it would exactly cover that difference, so he'd actually be the same. But he could also potentially be better off, because if he started buying more used books, right, after this change, he'd then be spending less than $1,080, depending on what his mix is between new books and used books. Okay, number 10. I had a price of 2, and then he bought 10 and 2, And I had 15 and 15. Okay. Again, I'm just adjusting it to make it so that it's the same as mine here. So if he bought 10 and 2, what would his budget be? He would be spending 10 times 4 plus 2 times 2, which would have given him $44. And then if both increased by 15%, well, we actually don't even have to calculate anything. You could, right? So you could calculate 10 times the new price plus 2 times the new price, which is 15% higher. But we actually don't even have to calculate anything. Because both of them are increasing by 15%, then the total CPI is going to be 115, which is going to represent a 15% higher amount. Now, if these had not been the same percentages, then I would have needed to multiply 4 by 1.15 to represent the 15% increase, and then multiply the $2 price by a 15% increase, so 1.15. Find out what the total expenditures are, and then use my equation where CPI equals total expenditures in the current year over total expenditures in the base year. And in this case, it would have been 44, and then you would have had some number here, times 100. Okay. Number 11. In number 11 here, I have a basket of goods, consumer income at $200. I have prices of 20 and 25. And then I have, in my case, I have 150%. So I'm just going to change this here just to reflect my notes here. Using the income ratio and consumption bundle, what is the rate of inflation? Well, then what you're going to see here is that I've got one increasing by 150, the other decreasing by 50. And so what that's going to do is that the total increase then, the total increase is going to be 100%, which would mean now that I'm going to be at 16. So if 8 times 25 is 200, right, which reflects the 200 here. And if the price X goes up by 150%, right, P subscript X is now going to be 50, right? That would be 150% of 20. PZ, prices are decreasing by 50%, so now it's going to be 12.5. Sorry, I didn't want this actually. Not that, sorry. Let's see here, exit drawing. Okay, I don't want this. I'm just going to cross it out like this. Sorry, I made a mistake here. So if I divide my $200 budget by the now new $12.50 price. I'm going to be at 16, which is mine right here. And if I divide 200 by 50, it's going to be 4. So now my budget constraint is going to look like this, which is going to give me overall a 50% increase. So I've got one going up by 150, the other one going down by 50. But given their relative size, the overall change is going to be 50%, which is going to mean, is it going to be possible for the consumer to buy the original bundle of goods? No, because now this point exists outside of this new budget constraint. So the answer here will be no. Sorry, 12. Okay. Here, I've got income of, in my case, mine was 2,000. And I had 20 and 20. And I had the person buying 10 units of goods. 10 and 10. Okay. So the first question is how much income would be required to buy the same quantity as before. So they used to be given these $20 prices. If they had 10 units of X, then they were also 10 times 20 would have been 200 total dollars. Now the price is going down by 10%. So that would mean that it's now going to be $18 for P subscript X. Price of Z is going to change by a positive 10%. So it's now 22. Then if X equals 10, which is what we're told right here, then Z would have equaled 90. How do I know that? Because PXX plus PYY equals 2,000, which in this case then was 20 times 10 plus 20 times Y equals 2,000. Okay, sorry, Z. Sorry, it should have been a Z. Make all my Y's Z's. Sorry about that. Z equals 90. How much income would be required to buy that same quantity of 10 and 90? Well, then I'm going to do same equation here. PXX plus PZZ equals $2,000. Or actually, we don't know. Actually, that's what we're solving for. Sorry. So that would be 18 times 10 plus 22 times 90. Which is going to be 1980 plus 180. Which is going to equal 2160. So I'm going up from 2000 to 2160. So my income is 2160. What is my rate of inflation? Well, it went up by 160. And what we would see here is that that is an 8% difference to go from 2000 to 2160. And then is it going to be possible to buy that original bundle of goods? Not at this price. We're not going to have that money. It's cost 2160 and we only have $2,000. Okay. Pause here for a second. Okay, Joe is going to get 365K. And this used to be his working leisure constraint. Price of consumption is $1. Okay, so we're asked here, we're going to need to draw out the budget constraint after winning the lottery. Essentially, what that would do is it would start things here at the 365 point, right? Because he could do no work and just rest all the time. Or presumably he would have some combination where the slope of this is 1-to-1. The same slope as this. So these lines should be parallel. So with that being the case, what is the income effect of the lottery games? Well, in this case, it's going to be zero. It's zero because in this case, at least at the if the person's going to keep working the same number of hours each day as they did before, then they didn't change how much leisure they had, which is what they're purchasing. They didn't change how much leisure they had based on having more income. So the income effect would be zero. Now, what about if Joe got paid more money? Now, if he got paid more money and our income effect is still zero, then he's actually probably going to work more hours because he has no income effect, right? So he could have already crossed out this and this. And so I'm kind of left with these three. He's actually going to work more hours because now the trade-off is it's a little bit more expensive to be having leisure time because your wage has gone up. So because of the substitution effect, which always works in the same direction, where that person would work more hours because the only thing they would have is a substitution effect. Can't have a negative substitution effect. That would be craziness. And we also wouldn't expect that they would work the same number of hours because that would imply that the substitution effect is also zero, which can't ever be the case. Number 14. So in this case here, we have someone that's running for president and they want a flat income tax where the marginal tax rate is constant. This isn't too extreme. There was that guy, I think he died, but he was running for president and he had this plan where he wanted everything to be 9%. It was called like the 999 plan. But I think he's dead. I think he died because of COVID or something. Okay, so let's start to work through this here. Okay, so they have a $10,000 amount, which is a personal deduction. So that's why things start to get kinked here. Correspond to that. Okay. Okay, so actually we don't need to um, well, yeah, I guess you would have just been drawing this. Okay. So actually all we need to do really is answer this here. So with the flat tax, what would we expect would happen? Well, the whole idea here is that a flat tax, the idea is that production is going to increase. It's a ploy to try to say that the economy is going to grow, and the reason why we're thinking it's going to grow, the only way that that would work is if you thought the income effect was stronger than the substitution effect, such that by decreasing the amount of taxes, people would have more income, and with that additional income, they would buy more goods, and that would offset. Will at least be larger in magnitude than the substitution effect. Number 15, I'm actually not too concerned with you doing this. I can't remove it after the fact. If you want to work on it, that's fine, but I'm not going to be holding you responsible for number 15. And so, in the interest of time, that takes care of number 15. Number 16. It takes us to number 17 here. In number 17, we're trying to choose between childcare and work. And so in this case here, what we can see is that if the government provides a lump sum subsidy, what it's going to do here, right, is it's going to change the relative price of daycare. And so we would expect that individuals with this subsidy would be able to buy more childcare, thus causing our budget constraint to change. And what we would expect is that individuals, at least if they were poor, right, and we just gave them a subsidy that could be not only used on childcare, but let's say anything, rather than only having to be devoted to one thing. What we would see here, you can kind of see this in the graph here, is that the subsidy is going to partly go. They're still going to buy childcare, but what we're going to see is that they're going to buy additional. They're going to buy the other goods. They're going to use some of that subsidy for the other goods, and it's actually going to result, rather than a subsidizing childcare, it actually could lead to the perverse or the unintended effect that the individuals would consume less childcare. Now, the question would be, well, I guess fewer, I guess is what it's giving us as an option here. The question would be, well, why is that happening? Well, what we see here is that it's going to change. And you can kind of see that here is that if we try to look at both our income effect and our substitution effect, that in terms of a lump sum subsidy versus an hourly price subsidy, the lump sum subsidy is going to parallel shift out the curve from L1 to L3. The hourly price subsidy is going to make my budget constraint now, instead of L1, be L2. But what we can see is that with L2, they consume less childcare, Q3, rather than Q2, which was the lump sum subsidy. So, in essence, the individual is better off. We're better off using the lump sum subsidy rather than subsidizing the hourly price. Okay. Just want to make sure here I'm running out of time here. Actually, these remaining ones are actually all graphing, I believe. Actually, so I'm gonna. So actually, this is in some sense definitional, talking about substitution and income effect, and just kind of tracing out how they exist. Same with here. This is actually, again, largely definitional, talking about still the substitution and income effect. And here, you're actually doing the same thing. Okay, I'm just going to stop the video now, just in terms of time constraints. I don't want this to get too long, but if these graphings, if your graphs don't turn out properly, send me an email and we'll kind of, I'll try to focus a little bit more time on it specifically.